All right, for question number 8, select the table that represents a proportional relationship between x and y. Now, in this case, you will have to check through all questions A, B, C, and D. And the way we would do this is finding the constant, which would be the y divided by the x. So for the first one, in letter A, I would just go 1 divided by 2/9, and that ends up getting me, which gets me 9/2. Then I would do the next one, which is 2/5/9. And this, however, gets me 18/5. And already I could tell that they're not the same constant, so letter A is not a possible solution. So that's incorrect. Now for letter B, I have 1/4 divided by 1/2, which would mean 1/4 times 2/1, which is 2/4, and that simplifies to 1/2. Then in the next one, I could go 4/4 divided by 2/2. I could solve those. 4/4 is 1, and then 2/2 is also 1, so it's basically saying 1 divided by 1, which is 1. So as you can tell, 1 and 1/2 are not the same constant, so B is also not one of our answer choices. So I would mark that one. It's not correct either. So now for C, I have 2 divided by 5/8. And that gets me 16/5. And then I can do 4 and 1 1/8. 1 1/8 has to be changed to an improper fraction, so I change that to 9/8. So now I'm going to go 4 divided by 9/8, which gets me the answer 32/9. So as you could tell, 16/5, 32/9 are not the same answer, so that's not a correct answer either. We can make the assumption that the last one is probably going to be our answer, but we need to still double check. So now we're going to go 1/4 divided by 1 1/2, which is really 3/2. So 3/2, and then we get 1/4, and we multiply by 2/3, which gives us 2/12. And that simplifies to 1/6. Then I have 1/2 divided by 3/1. And if we divide that, that also gets me 1/6 because we multiply by the reciprocal. So we have now officially found that letter D is our answer, since it has the same constant rate of change of 1/6. So as long as every fraction of y over x equals the same thing, that means they have the same proportional relationship, the same constant. For question number 9, Darius has 24-ounce sports drink. He drinks 18 ounces. Enter the percentage of ounces Darius has left of his sports drink. Now, in order to solve this problem, it's a percent of change. So what we would do, we would take the 24 ounces, subtract the 18, and that leaves us with 6. So he has 6 ounces remaining. We take the 6 ounces, we divide it by the original amount, which is 24, and it gives us 0.25. And that's a decimal, and they're asking us for a percentage. So what we do is take that decimal point and move it 2 places, 1, 2, over to the right, and that leaves us with 25%. So the question is asking how much of the percentage of sports drink does he have left? He has 25% left. Now for question 10, Candace makes a sugar-water mixture for hummingbirds. She knows the amount of sugar used in the mixture is proportional to the amount of water used. Which of the following could represent the relationship between the amount of sugar and water Candace should use in the mixture? I do want to point out they are specifically stating that this is a proportional relationship, so you are looking for a graph that shows a proportional relationship. Now, let's start with letter A. So if you look at letter A, it starts off with 1 cup of sugar, and it's going to be a little bit over 4 cups of water, and then 2 cups of sugar ends up being at about 4.5. So there's one thing I do want to point out. When a graph is proportional, it should be going through the origin. And as you can tell, it is not starting at the origin. It is starting at 4 cups of water for 0 cups of sugar. So therefore, that's not proportional because it's saying the amount of sugar is proportional to the amount of water used. And then for letter B, we know that it's going to be proportional, meaning that every time you increase the amount, it should also increase the amount of sugar, the water amount of cups should also increase. It should not be just a flat proportional relationship. So in this case, since there is no ratio for each mixture, then this also is not a constant. For letter C, we do notice it does start on the origin, but then we see that up here it looks pretty consistent for every 1 cup of water, and there's a 1 cup of sugar. Then for 2 cups of sugar, there's 2 cups of water. But then all of a sudden, it breaks off right around 6. And then the proportional relationship changes. It has to be consistent every single time. So once the constant is broken, it's no longer proportional. So that is also incorrect. We can assume that letter D is our only option as our answer, but let's double check. 1, it starts at the origin, so we understand that. Then the proportional relationship, for 1 cup of sugar, it is 4 cups of water, okay? And we just want to make sure it's constant. So for 2 cups of sugar, it is 8 cups of water. So remember, the constant is when you have y over x. So if there were 4 cups of water for every 1 sugar, then 8 cups of water for every 2 sugars, that also reduces to 4 over 1. So we just proved that it is constant, it's consistent, therefore being proportional. So letter D is our answer. For question number 11, the graph shows the linear relationship between commission earned, C, by a salesperson and a number of sales he makes, S. Find the constant of proportionality, R, using the value for R. Enter an equation in the form of C equals R times S that represents the relationship between the commission earned, C, and the number of sales, S. So again, they are telling us that this is a linear relationship, meaning it is consistent and there is a constant. So it is proportional, therefore you should be able to find that R. So what we would do first is take a look at the values they provide for us. So we notice that we can start for the number of sales. For every 1 sale, there's $8 earned in commission. For every 2 sales, there's $16 earned. Then for 3 sales, there's 24. For 4, there's 32. So at this point, we can see that there is that consistency. So we know it starts as 8 to 1. Then it goes 16 over 2, which also reduces 8 to 1. Then we can go 24 over 3, which reduces to 8 over 1. So therefore, we just realized that the constant is this 8. So R is going to equal 8. And when we write our equation, we can simply write it as C equals 8 times S. And then that would be our equation. Because for every sale, it's going to be an $8 commission. For question number 12, select all tables that represent a proportional relationship between X and Y. So in this case, there are going to be more than one answer. Make sure you check by using the constant of y over x. So you are using a ratio by dividing y over x. So for the first one, I can go 10 over 1/5, and that would end up giving me 50. But then I want to double check, so I'm going to go 20 over 2/5. That also gives me a constant of 50. And then I'll just double check that last one to really make sure. 30 over 3/5, and that also. So for the first answer, that is a true statement, so that is correct because there is a constant proportional relationship. Now for the second one, I'm going to go 1/8 divide by 1, which is 1/8. Then I can go 3/8 divide by 2. And that gives me 3/16. So automatically I could see that since they are different, this is not a correct answer. Now for the third one, 1 divided by 2/7 would get me 7 over 2. And then 7 divided by 4/7. And that ends up getting me 49 over 4. So here I notice that is also not a correct statement because it is not constant. And our last one, we have 1 divided by 1/4, which gives us 4. Then I can go 2 divided by 1/2, which also gives us 4. So, and then 3 divided by 3/4 would also give us 4. So that means it is constant. So the last one is also a possible answer. In question 13, the diagram shows how much sugar is mixed with water in a hummingbird food recipe. Enter the number of cups of water used for 1/4 cup of sugar. There are 3/4 cups of sugar for every 3 cups of water. So now we need to figure out how many cups of water would be used for 1 full cup of sugar. So now what we would realize is that for every 1 cup, it is a 1/4 cup of sugar, because we could break it down by dividing the 3/4, divide by 3, and that just tells us there's 1/4 cup for every 1 cup of water. So if we're going to have a full cup of sugar, we're adding another 1/4. So if I add 1 more 1/4 cup of sugar to equal 1 full cup, then that means there needs to be 1 cup of water. So therefore, it would take 4 cups of water for 1 cup of sugar.